So recently I've been looking at the Blender subreddit and I keep seeing these like geometry node renders where spheres are deforming these like cylindrical pegs, and there's a bunch of different versions of this, but I thought I'm gonna make my own. I'm gonna teach it and I'm gonna separate it into two parts, which might sound like a bad thing, but I'm doing it for convenience sake, where part one, this one, is gonna it's gonna be about geometry nodes. Hopefully I don't stumble throughout the whole thing. And part two is gonna be, now that we have this like node network and everything works, how do we render and give this thing material so it looks aesthetically pleasing? So part one, this one, technical. Part two, artistic. So we got a cool little balance. So first of all, what is it that we are going to be making? Well, you already saw the render. I haven't actually hit render yet, so I don't know exactly what it looks like, but it should look something like this. We basically have two spheres. They're circling about each other, they're bobbing up and down, and that deforms pegs that exists in the surface. What's really going on is these are kind of like going off until infinity, and we'll talk about why that is. This whole thing is just like an illusion to hide kind of the mess of what we're making, but this mess does have a lot of controls that we're going to talk about. So for example, we can control the resolution, how many pegs exist in this like fixed domain. We're also going to talk about the speed. I want to be able to slow these down, and I want everything to work. I want to be able to speed these up, and I want to be able to reverse the direction. We can do all of these things. Additionally, I made a phase control, which I think the way I've made this work is the closer it is to 0, the closer they are going to be to each other, so you can have them trail each other, or you can have them really be, I think pi is the exact number, you can have them really be offset from each other, and we can control the bobbing. So when it's set to 0, they're just like that. When it's a big number, they bob up and down probably a bit too much. So we're going to talk about how to do this. But before we begin, just long story short, I just want to kind of build up the scene a little just so we know what's going on. The first order of business is we are going to be making this circle generator that we can control the size of, and like I talked about, the resolution of. Once we have this circle generator, I'm then going to basically instance a bunch of cylinders along it. So again, we can control the resolution, whatever. We're then going to make these two spheres that move. We're going to use that to calculate the proximity to these cylinders, and it will, give us this, and then we're just going to join everything together. Long story short. Okay. I think that is enough intro. So, new Blender project, I'm going to be using alpha version 3.0. You can try 2.93. I don't know if all the geometry nodes I'm going to be using exist there, especially stuff like material sign. I don't know if that's made the cut yet. It might have. If you want to make sure it's compatible, use 3.0 as well. But, take the risk, okay? All those medications say you might die. Your baby might die if you're pregnant, but you can still take it. It's up to you. That's what this is. So either way, we're started. So geometry nodes, what we're going to do is we're going to take this cube. Let's actually name this because I always forget it. So this is going to be our GeoNodes object. I'm going to make a geometry nodes node graph, which again makes a modifier, and I'm going to delete this group input. So again, we've started off with a cube, but we've deleted it, and we're just using this as a basic generator for our geometry node. So forget a cube ever existed. First order of business is, again, how do we make that circle that expands and contracts and all that? Well, you might think that's simple because you're like, oh, there's mesh primitives, there's a thing called circle, perfect, you add it. There is an issue though. Even if you set this to n-gon and it's filled, there's no way to actually get these vertices that are along the rim to be on the interior easily. Because remember, we don't just want a circle, we want a circle made up of a grid of points. So how do we do that? Well, I already told you, a grid of points. So the key insight here is what we're going to add instead of a circle is we are going to start off with a grid, which is just a fancy word for plane. We call it a grid because the more vertices we add, it fills up the grid. If we can somehow take this and delete kind of the border, so it kind of looks like a circle, then we've done it. We've started off with a grid and just gotten rid of the thing and shaped it into a circle. So that's the key insight. That's how we're going to do this. So let's think about how to turn this into a circle. Well, a circle is basically defined as the region or the set of points that are equidistant from the origin. So a circle is basically all the points that are of length, if you think of these in terms of vectors, right? Because each point has its own position, x, y, z. A circle is basically all the points that whose length fall within some threshold. Okay, let me explain. So what we are going to do is we somehow need to extract the distance of every single point from the center. That's something that attributes are useful for. So what I'm going to do is I'm going to add in an attribute math, but since this is a vector operation, we're looking at the position, a 3D vector. I'm going to look at the vector math. So attribute vector math. Same as attribute math, it's just for vector inputs and outputs. Okay? So you can see in this attribute vector math, I can say for our attribute that I want to do some math to, I can click this, and position's already an option because it's already an attribute of every single point. So I'm going to take the position, I'm going to output the length, the magnitude, the radius from the center, and I'm going to write that into a new attribute called @circle. So again, what this means is I'm taking this input A, which is position, so I'm looking at the position attribute, I'm calculating the length of that vector and writing that data into circle. So you can see now we have a one-dimensional kind of distance output for circle. Okay? And you can see some of these are further away from the origin, some of them are closer or whatever. So we've outputted the lengths, and now what we want to say is which ones fall within our criteria, which ones are within 0.5 of the center or 0.3. To do that, now we're going to need to do another process to our attribute. So this time it's going to be attribute math because we're no longer dealing with vectors. You can see it's a one-dimensional thing. I'm going to input the circle. I'm going to see whether it's less than or greater than some number. So I'm not comparing two attributes, but a attribute and a number. And then I'm going to write that data to, well, I guess we could write it back onto itself is one way we could do it, or you could do a new attribute. I'm just going to do a new one to keep it clean. I think in my original I just overwrote it. I'm going to call it delete. This is basically going to be the set of points that don't make the cut or do make the cut. We'll see. Either way, I'm going to take this number and increase it, and you can see as this number gets bigger, a lot of these turn into 0. So let me make it so that there's less data here. So you can see right now all of these make the cut, and then as we increase the radius, you can see some of them do, some of them don't, etc. And basically these are the points that are within 0.5 radius make the cut. Either way, you take this, you filter it through a delete geometry node, you say what geometry do we want to delete? Well, we made this nice delete attribute. Okay, and this is where having more geometry is going to be useful. So you can see what this has done is it's made a circle. And now we can visually see what I was talking about, where this number is basically the radius. So again, all these points that were in the original grid and the corners that are gone, these are points that are not greater than, or they are greater than. They're greater than this radius, because I'm saying if it falls outside of the circle, just delete it, okay? Which means when we get to closer and closer to 0, almost everything is deleted, because almost everything has a magnitude larger than 0. Either way, now we have a nice controller, so I'm just going to pick a number that gives us a nice looking circle, and it's also good to pick kind of the resolution you think you're going to be using. So I'm going to be using 40 by 40. You could also use a rectangle, but you know, I like the aspect ratio to be 1 by 1. Okay? We have a nice circle generator. So again, we made a grid, we're looking at the length or the magnitude of this position attribute, and then we're saying make a cutoff, and if it doesn't, delete it. Okay? Long story short. Okay, now that we have, I ate a peanut and I might be allergic. Either way, now that we've made our circle generator, let's take advantage of it. Not in that way. Let's take advantage of it and use every single point to spawn in a peg or a cylinder or whatever. So let's just save this. I'm going to call this thing something nice and memorable that is useful to us, like available on Patreon. If you want to get the bun file when we're done, or the original, you can get that on Patreon, but link in the description. We'll move on. We want to take this and spawn a cylinder on every single object. So what I'm going to do is I'm going to add in a cylinder, and I know what you're thinking. Why did you not just, add in a cylinder, in geometry nodes, right? You could just do it like that. The issue with this is that it doesn't actually let you, as of now, it doesn't let you instance. So I'll show you what I mean. I'm going to take this, I'm going to add in a point instance onto our chain, and we want to say, what do we want to instance? Well, it's going to be the cylinder. What do we want to copy onto every point? The cylinder. You can see that this requires an object input. So either way, I'd have to make it in a outside of this node network. So you can see these cylinders exist, but they're way too big and they're overlapping. So what we need to do is you can either go into edit mode and scale them like this, or what I prefer, just so we have a nice control all in this node network, I'm going to add in a point scale node. So basically, I've created the circle generator. I'm then going to define what the points look like, and then I'm going to instance, the cylinder on every single point. So let's start by making these smaller. Probably good to look at the top view. I want to see right when they stop overlapping. So I'm just going to scale them all together by the same number. So they're still slightly too big. Let's try 0.01. Now they're too small. I want them to be barely touching tangentially, and that seems to be roughly the number. There can be a tiny bit of a gap. If you want, you could find the exact number. I imagine it's something close to 0.120125 or something like that. Do whatever you want. So now we've scaled these, and since this is a vector kind of scaling operation where I can scale only on the x or only on the y or only on the z, I'm just going to make them taller because we can, and it'd be easy. And this is another thing you can make a controller for your modifier later on. Okay, cool. So now we have our cylinder generator. We have a radius, we have a resolution, and this is something that I'm not going to mess with it too much, but if you wanted to, actually let's just do this via a group input. These are things you can make nice little controllers. So making this resolution X and Y is something we can control from here. That's what adding it to the group input, this is an input, does. We can just control it from here. Okay, cool. So we've generated our grid that's nice and procedural. We can do whatever we want with it. And that's already a valuable lesson. You're welcome. Now what we need to do is we need to make these sphere objects or whatever you want them to be. We want them to bob and rotate and all this. And then we somehow need to do some kind of calculation that says cylinders, or points really, look at how close you are to the sphere. And if you're close, deform downwards and do that thing. But first of all, let's add in the sphere. So again, I'm going to need to make this outside of geometry nodes for now. Although you could argue with this one, you could actually, you could totally get away with not doing it in geometry nodes. Or sorry, not doing it outside. You know what? Let's just try it. Whatever. I didn't do this for the original, but let's live on the edge. So let's try adding a UV sphere. So you can see here's our sphere. What we can do is we can take these two, and I want to see them both at the same time. So I'm just going to join geometry. Geometry 1 is basically our pegs. Geometry 2 is our sphere, and now they're both existing. It is a little bit confusing because the sphere is bigger than the pegs, so you kind of have to look inside the interior to see it, but whatever. Because of that, we need to make it smaller. So let's do a transformation. Yeah, there's no reason you can't just add in the sphere from here. I mean, it does give you a bit more control with the segments and all that. You can change later, but whatever. Doesn't really matter. So we take the sphere. I want to make it a smaller sphere, so I'm just going to scale it down until it's like roughly the size that I want. Again, we can always go back and change this. So that's one advantage. But really what I care about is like moving this thing with this translate. Right? I want to translate it in a way that it's moving in a circle and it's bobbing up and down. In other words, this translate vector, we need to give it a nice custom function to make it work. So what I'm going to do is I'm going to isolate this thing, so combine x, y, z, so now we can control all of these individually and put in math expressions. And what expression do we want to put in? We want to put expressions into the x and y. In other words, the two axes that our revolution is going to go around. I want to put in functions into the x and y that make it circular. And if you remember from trigonometry, sines and cosines do that. I've been talking about sines and cosines every tutorial. So really, study them if you don't get it. So first of all, I'm going to add in a kind of a input angle parameter. The way I'm going to animate this is the same way I've always done it. Hash frame is basically an expression that creates a driver that on frame 1 gives you 1, 2 gives you 2, 3, 4, 5. It looks at the frame number and outputs it out, okay? It's a nice way to do this without keyframes. I'm going to take this, I'm going to make it a bit slower because right now it's expanding way too fast. It's going up like by integers. I want it to go up by like maybe 1/10 of an integer. So this is going to slow down time by a factor of 10 if you want to think about it like that. We want to take this and send it through some sines and cosines. So for the x, I'm going to use cosine. For the y, I'm going to use sine. It isn't that important which one you do it. It's just that this is the standard convention. And you can see that now we have this orbiting. We can also slow it down. We can also put in a negative thing and it will go the other way, right? This is how I made those controllers from before. Cool. Issue is it's kind of going outside the region that we'd want it to. So we need to take these sines and cosines that describe the position of a point going along the unit circle, and we want to say, don't make it a unit circle, make it a tinier circle. In other words, we take these outputs and we multiply them. Oh, by the way, it's interesting when you stack cosines on top of each other, it gives you some weird motion. Either way, we want to take these and then multiply them by some number smaller than 1. Whoops. Multiply, and let's give this the same number. So I'm just going to hook up a value, and now you can see we basically have a radius controller, if you want to think about it like that. Okay. So let's make these things parameters, because I guess they're useful. Or actually, let's not do that yet, since we're probably going to add in a second sphere, so I just want to set all that up. So I'm just going to pick a nice radius that I feel like is the correct number, so 0.32 is inside of it. It also depends on how big our sphere is going to be, so whatever. Pick a number. Also, I want to add in that bobbing motion up and down. You could just add in a whole nother function, or I'm just going to do it the lazy way. I'm just going to use one of the cosines from before. And now you can see it's going to be bobbing up and down relative to the cosine wave. And to make it bob less, just like before, we multiply it or scale it by like some small number, like 0.1. We make it 1/10 as strong as it would have been. So you can see this thing is now bobbing and weaving. Here's it isolated, and here's it together. Okay? So now what I'm going to do is I'm going to use this geometry, this moving geometry, this set of points, to dictate which cylinders move up and down. And then once we do that, we can just add in another sphere or however many you want to. Okay? So the question is, how do we now move these cylinders? Well, long story short, what we can do is we can use a point translate node, which literally move our points. And what we want to do is we want to move them up and down on the z-axis, but not all together, relative to some attribute that we're going to make, where some cylinders are going to move up more, some of them are less, and that's going to be defined by the attribute. So what attribute are we going to make? Well, it's going to be a proximity-based one. How close is it to the sphere? Okay, to do this, I don't think it matters what order of operations we do here, so I'm just going to throw it in right here. I'm going to throw in an attribute proximity node. Yes, there is a node literally for this, and it's useful for any kind of how close is something or far away is something effect. The way it works is we take some input, so in other words, our grid of points is going to be the input. I'm going to say, take this geometry, and I want you to look at the target, being the sphere, and we're going to output that distance. So again, what it's doing here is it's taking some geometry, these circles, it's comparing their distance, every single point, to this geometry, relative to the faces, the points, whatever, and we want to write that distance into a new attribute. I'm going to call that distance. Okay? So right now, we shouldn't really expect anything to happen. Like, we've done the calculation, it exists, and I think we should be able to see it right here. So here's our distance column, and you can see that, you know, every time I pause this animation, which you can't really see what's going on, but every time I pause it, these numbers change because, you know, the sphere is moving. We've written this data, but we haven't done anything with it. So let's just visually do something. So with this point translate, this thing that's going to go up and down, I'm just going to change this to an attribute, and I'm going to say, do something with our distance. It's not going to look correct, but it does give you the idea that it is working correctly. And I think the way proximity works is it's kind of like a inverse. Well, it's not an inverse relationship. It's exactly what you would expect. The further away a point is from our sphere, in other words, right here, these points that are super far away, they're going very high up because their distance is much larger. Where the points are close to the sphere, that distance is close to 0, and they're almost touching the sphere, right? So that makes sense. What we want to do is we want to filter this through some math that gives us not this, but whatever it is we want, okay? So the first thing I'm going to do is this distance, you can see, is a one-dimensional kind of thing, right? Because it's just outputting the distance. The issue is this point translate, the way that it's working is it's taking that and it's translating on X, Y, and Z. So we need to somehow treat this as a vector, even though we already know that it's not, to make this work. So here's how I'm going to do it. I'm going to use an attribute vector math, because again, we want to turn this into a vector even though it's a float input. What I'm going to do is I'm going to take this, and let's say, and this isn't going to be the final function, but let's say we multiply it by some vector. So if, again, we have 1, 1, 1, we have the same issue. But I think if we take X and Y and suppress them, now we have something that looks a bit better. Yes, it's still like distorted, but it's not what we had before. So now it's just going up and down on the Z. If we look at this from the top view, it should not look like it's changing because it's only going up and down on the Z. And you can control the size of that effect. So now it's going to be very gradual, and we have something working. What we want to do is kind of take this and invert it almost, so that the points that are close to it are the ones that are going down, not the ones that are far away. There's a lot of ways to do this. Kind of the obvious way is basically we have this like distance going from 0 to some number, the maximum distance. You'd want to take that and just flip it. I'm going to do it in a different way because it visually looks cooler. What I'm going to do is I'm going to divide. So where the distance is very close at 0, we're going to do 1 divided by 0. So it's going to go infinitely far down. That's why we had that before. It's because of the division. And wherever we have something going very far off, large distance, 1 divided by that, it's going to be very close to 0. It's going to have a fall off effect. So it just kind of works nicely. So I'm going to set this to division. And now I'm going to kind of invert this, where we're basically going to take the vector. So again, 0, 0 on X and Y since we want to suppress them, but we want to have 1 divided by the distance. And that kind of almost gives us what we want. So you can see this like infinity thing going on wherever it's close to the sphere. Just to make this work, I think you just take this number, and I don't know what it's supposed to be, but it's supposed to be, whoops, only the Z. It's supposed to be something smaller. And you can see when I set it to, I guess it has to be a negative number is the key insight. When it's 0, nothing happens. When it's slightly negative, we get what I was talking about. So again, the way this is working is the negative is going to flip the polarity. So now it's going down instead of up. So if we had it the other way, it'd be the inverse, which is a cool effect in its own right. But again, whenever it's very close to the sphere, it's going off to like in negative infinity, right? Because it's 1 divided by 0 in the negative sense, or negative, whatever. You get the idea. Either way, this is a nice working proximity effect, and because it works with the bobbing, you know, we get a cool looking motion. So we could, you know, fiddle with this a bit more. The only thing I would recommend is if you want to really control this a bit more, and you could control the fall off. You could make it a inverse square instead of just an inverse. But one thing that I found is pretty useful is I'm just going to add in an attribute color ramp. So yes, you can control attributes just like, you know, shader nodes with the color ramp. Basically, I'm going to take this distance. That's what I'm going to modify and just overwrite it. So whatever edit we do here is just going to overwrite back onto the distance. You can see that we can make kind of like different customizable effects. And really, you just want to take this top slider and drag it down. This is saying how far away does it need to be very affected. I'm probably only going to bring this in a little, so the boundary is a bit more conserved. But in general, I'm not going to mess with it too much. The key insight, the key mover, how many times have I said key insight in this tutorial? It's the division, okay? Cool. Now the nice thing about this is since we've set this up, the entire shit's procedural, right? I could set this to a different number, it would still work. I could set this to a different kind of like scale, it would still work. You could even make it a rectangle. Now that we've done all this, we can get extra visually appealing results for free. So for example, one thing I did is instead of having 1 bobbing sphere, let's have 2 bobbing spheres, and this is why I didn't make them parameters yet. Okay, so what I want to do is I want to make 2 bobbing spheres. In other words, I'm going to start with the same geometry, but I'm just going to translate them a bit differently since I want them to be a bit offset from each other, not on top of each other. So I'm going to take this, I'm going to join geometry, so now we're going to have 2 spheres that are working together. So you can see now there's kind of a sphere hanging out here that we control independently. What I want to do is kind of create a similar thing, but offset the angle by a bit. The way we do this is, okay, so we take this, we divide by the time by 10, so it's slower. Here is where I want to add in some number, because if you remember trigonometry, this is called the phase. So you can see it's just gonna keep the same speed, but we just kind of offset it a bit. This is where we want to add in a thing, and then make it its own like little chain. So I'm thinking what we do is we take all this, everything after that, and Control G to turn it into a node group. We'll see how this works. I'm going to take this, and then this was 0.32. I'm going to take this, I'm going to copy it. So this is going to have a slightly different version. And for this one, I'm going to give it the same input, which is going to make it so that there's two spheres on top of each other. But the only difference is I'm going to add in a number here. So you can see now it's almost like they're chasing each other, and I know the proximity effect isn't working on the second one. We'll fix that in a second. But you can see that they are now kind of chasing each other. Again, this node group is basically, well, this node group, I just heard some like haunted noise. This node group is basically our sine and cosine generator, and I'm just adding in a bit of a phase, so it's a bit offsetted. And it turns out, because it's trigonometry, if you make this pi, in other words, 3.14, they're going to be exactly offset from each other. They're going to be polar opposites. But now we have this. Why is it not, doing the proximity thing, right? We've taken these two, we've joined them. Well, let's look at our node network. Again, this proximity attribute's where all the magic's happening, and we're only bringing this one in. We need the join geometry. So let's just do it like that. And you can see this is really the power of geometry nodes illustrated in just one single operation. You get one thing for free, and then you build on top of it, and then it just gets more and more complex without too much work. So I could just totally add in another sphere, or if I wanted like 10 spheres, I could make a little ring where each of them instances its own sphere, and we could get more complicated. But for now, since we're doing two, I'm just going to set their transforms manually. But maybe Patreon exclusive, I'll talk about how to make like 10 spheres or something like that. Okay, so now we have our thing. Let's make a few controllers. So for example, this one is going to control the time like we talked about. So we can make that its own group input. So this is going to be a modifier based thing. I'm just going to name these. So N for this panel. This first one is going to be our resolution. So let's call it resolution. The second one is going to be our speed, so let's call it speed, and it's fine that it can go negative or positive, because again, remember, if I make it negative, it reverses the polarity, right? There's use in that. I also want to add in a controller for this, I'm going to call it phase. And phase, I should probably make from 0 to some number so that you can't go negative. This is basically going to say how far apart should they be. When it's 0, they're together. When it's slightly above 0, they're chasing. When it's pi, they're exactly opposite from each other. You could make some other parameters. I'm not going to make this greater than slider one because I don't think it's that useful. You can go back here and modify it. Some obvious things to do are you can make your point translate a parameter, but you could fiddle around with this. There's just two more things I want to do before we're done with this technical part of the tutorial. First of all, you're going to notice these spheres, they're still like, they're jagged. And the issue is we can't actually shade smooth onto this because it's a geometry node thing. It's weird. So I need to, first of all, tell you how to make this shade smooth. And second of all, I'm just going to make a little like frame that this exists in. So to make this shade smooth, I'm going to look for where the spheres are. Remember, they're right here. We join them together, right? What I want to do is I want to take this part of the chain, and I'm going to attribute fill. This basically says take an attribute or make an attribute and fill it with the same number for everything. But you can see there's an attribute called shade smooth already. It's inherent to the thing, and I think that exists. I don't know where that exists actually in the network. But either way, shade smooth, you take this, you set it to anything other than 0, like 1, and it smooths it out because now we've made it smooth everywhere. That's what the fill does. If we put it over here instead, where it also applies to the cylinders, it would also shade smooth the cylinders, which might give us kind of a weird look, as you can see, which is why I did it here. Okay, beautiful. Now let's make a frame, and you could do this with geometry nodes, but there's no point. This is the kind of thing you just want to model. So the way I'm going to make a frame is I want to have a plane with kind of a circular cutout so we can make a nice rim. Easiest way I found to do this, and I'm sure there's more easy ways, I'm just Control-Ring to add loop cuts. I'm going to scale this so our circle is kind of like in this bounding box in this center face. And for the center face, I'm just going to subdivide a lot. The more geometry, the better. Take this, limited dissolve, and you're like, why did you do that? You subdivided it, and then you got rid of it. Well, not really, because if you look at the vertices, it's maintained these vertices. So now our interior face has a lot of geometry. You could run a two-sphere command. You can see I already typed it in because I've done this before. But a two-sphere command is basically going to circle this up. So you set it to 1, It's going to give us a perfect circle, and I'm just going to scale it until it's like roughly on the boundary. Okay. Next, I'm just going to model this a bit. So I'm just going to delete that center face. Well, actually, let's wait a second before we do that. So I'm going to select this center face. Did I already delete it? Take that center face. I'm going to extrude it upwards on the z-axis, and you'll see what I'm doing in a second. I'm going to extrude it. I'm then going to bevel it a little, just to give it a nice rim. And then I think we should be fine to delete this, or I guess we could inset it a little. I'm going to inset it, then extrude it down, then delete it. So basically what I've done is, let's hide this geometry nodes thing. I've just modeled a basic kind of like frame for this. So you take your frame, and then I'm going to scale it just so it's like, it makes a bit more sense. It's hard to get this perfect because the essence of this is it's a jagged circle. To make it nice on the boundary, of course, you could take your resolution and bring it up. So that's kind of the advantage here. Oh, by the way, if you increase the resolution, you might want to also add in a scale slider for this, but whatever. I'm not going to be planning to change it. Okay, so we've made a frame. I'm going to dip it down like that. Let's see what that looks like. That looks pretty good. Kind of want to see what I can get away with here. So at this point, it's really just preference what you want. So like, how tall do you want these pegs to be? I'm going to set it to like 0.055. Okay, we have a nice frame. And again, the idea of this frame is not only does this compose it nicely, but it hides the mess down here that we created. I'm going to take this. I'm going to select these edges. So this is just kind of setting this up for render. We're going to talk about this more in the second part. But we take this, we bevel it just for nice smooth lighting, shade smooth, and if that breaks your shading, obviously, auto smooth. Okay. Anything else with this? I don't think so. So currently, this is what it looks like. Let's get it to look more visually interesting, at least in solid mode. Enable cavity, enable outline, and enable shadow. This is really going to give it some readability. So you can see this is what we made with geometry nodes. It has all these parameters from before. You can control it. And now the essence of the rest of this is how do we make it look good. So because this is already running for a bit long, I feel fine separating this. So again, this blend file, it's going to be available on Patreon, but I think what I'm going to do is I'm going to upload the final one. So it has this geometry nodes network, but also all the materials, which I'm going to talk about in part 2. So if you're watching this as it comes out, I believe I'm going to make part 2. I'm going to make it now, but I think I'm going to upload it tomorrow, so you don't have to wait too long. But patrons get that early. And speaking of all that, now that we've made it to the end of this 30-minute tutorial, wow. Speaking of that, Patreon, it exists. Here's like nearly 800 people that are part of the Patreon. It's on one of these sides. First of all, thank you to all these people. But what do they get, and why should you maybe join? Link in the description. Well, you get the blend files for this, for anything I've made over the last 2 years. You get early access to tutorials. So, for example, you would not have to wait. If you're watching this now, you would not have to wait for part 2. It would already be uploaded. You also get exclusive tutorials that I do not upload on either channel. I've already uploaded a Geometry Nodes 3 at the time tutorial, so I made a nice little surface with particles on top of it. This is something that's only for patrons, so you could go check that out, but there's exclusive tutorials, there's updates, there's a whole bunch of stuff for both this and the CG Matter channel. So I appreciate anybody who either wants to do that to support both of those, or you just want the benefits, either way. But that exists, link in the description. Thank you for watching this. I hope you learned something about geometry nodes, especially about the proximity effect, which isn't to say like your voice getting deeper as you get closer to the microphone. Different proximity effect. Join me for part 2 when we are making materials. I will see you there. If you don't come to part 2, screw you. Bye.